Okay, so we're back. It's Monty, it's Shadle Park, it's geometry, and here we are in Mathia, Semester 2, Module 3, Topic 1, Unit 2, and we got interrupted in that last video, and we're on this triangle here. So we have the big triangle, and we're trying to find the corresponding parts of the little triangle. So we have this big side, boom, 41, to the little side, 17.1. The big side here, 4904, goes to this one right here, and then we call that X. So we had just clicked on our solver tool, so we just got to type that in. So we're going to have 41 goes to the 17.1 as 49.04 goes to X. Okay, and now we're just going to use our solver tool here. So I think the first thing we want to do is multiply both sides by X. And we'll get rid of that and bring it over there. Now we just have to divide by the 2.3977. 2.3977. And X is going to be 20.4533. Where are we at here? Oh yeah, we got to click on that, don't we? Okay, so 20.4533. Hey, flying palm trees, and I think we finished this unit. Sorry we got interrupted and we had to have 2 videos for that, but that's okay. Have a great week. Let me know if I can help. Cool, so I think partitioning segments and giving ratios. I think since we've only done a minute here, we'll just continue on that, okay? And that was 11 minutes. And then we're going to do partitioning. Okay, partitioning. We have 2 workspaces here. So let's see what we got here. Partitioning given segments and ratios. Now, you see how we have these segments here? So it's all about scale factor, 1 to 3. So let's watch this video first, see what they have to tell us.
Here is Jack. He is on a treasure hunt, looking for buried treasure. The last clue has him stumped, though. The treasure is located between the swings and the slide, 1/3 the distance between the two. But is that 1/3 the distance from the swings, or 1/3 the distance from the slide? These 2 points are actually different. Instead of a plain line segment between the swings and the slide, what would be more helpful would be a directed line segment, often called a vector. With a directed line segment, AB would mean the distance starting at A and ending at B. 1/3 the distance AB would be here, but 1/3 the distance BA would be here.
Okay, so now we've got to figure this out, partitioning. Watch the animation. Select the point that represents 1/3 AB. 1/3 of AB. So we need the 5, right? So 1/3 would be 5 units. So let's click here. Cool. So that represented 1/3 from A. All right? The length of the ratio is 5, 10. Whoop. See how we went 5, 10, 15? Okay. Now consider the segment BA. We're going to come back the other direction. 1, 2, 3, 4, 5, B, F. F. Point blank represents both 1/2 AB and BA. The middle point. That would be E. Looks like 7.5. Let's see if we can do E here with a capital. Nope. Cap lock E. Cool. Alright. So horizontal, I think this will be the same.
Jack. He is on a treasure hunt, looking for buried treasure.
Oh, different video.
The last clue has him stumped, though. The treasure is located between the swings and the slide, 1/3 the distance between the two.
No, it was the same video.
But is that 1/3 the distance from the swings, or 1/3 the distance from the slide? These 2 points are actually different. Instead of a plain line segment between the swings and the slide, what would be more helpful would be a directed line segment, often called a vector. With a directed line segment, AB would mean the distance starting at A and ending at B. 1/3 the distance AB would be here, but 1/3 the distance BA would be here.
Okay, so now select the point that represents distance 1/4 DC. 1/4. So we go from 12 to 16, so 4 units. 1, 2, 3, 4. I'm going to save this one right here. Cool. So these are 4, 8, 12. Right? 4, 8, 12. 4, 8, 12. 4 of the 12 units. Okay? Point blank are CD. 1, 2, 3, 4. Now let's try point P. And point represents the halfway point would be 8 units. 1, 2, 3, 4. 1, 2, 3, 4. S. I like it. Good. Ship it. Okay, so now.
Here is Jack segment between the swings.
Okay,
and
same
the slide.
idea. Okay, so now. Suppose WZ is directed line segment. Select the point that represents 1/4 of WZ. So 8 units. We need 2. X. 2 units of the 6. Yep. And point 1/4 ZW. I'd say V. Let's try V. And the halfway point would be Y. It'd have to be Y, wouldn't it? Yep. Good. Oh, we're cruising now. Partitioning. Okay? So now 1/3, and we got a diagonal. So select the point 1/4 the distance. So 1/4, 1, 2, 3, 4. JK will be A. Enter the coordinates you selected, 4, 3, and when we do this, we got to do parentheses. So 4, 3. Okay, the horizontal distance, the vertical distance, the point you selected represents fourth. Oh, we're doing fourths. And the vertical distance has to be the 4th. Okay? The point you selected, the lengths are in the ratio of 1 to 3. Yep. 4 parts, 1 of 3. Okay? Alright, 1/3 the distance. Okay, 1/3 DA. DA. 1/3, 2/3, 3/3. So we got point Q. And we got shift 9. 7, 3. Cool. So we got these distances. We got these distances. The points are 1/3 and 1/3. Everything's in thirds, but they're in the ratio of 3 to 9. 3 to 9, that's 6 items. 1 to 3. 1 to 2, 3 total units. Yep, blew that one. My bad. Okay, so 2 to 5. B to C. Okay, so now 2 to 5, 9, 8. 9,8 represents 2 to 5, represents 2 to 5. These lengths are in the ratio, they're 7 units, 2 to 5. 2 of the 3, and 5 total. I think we'll see if we can finish it. If we don't miss one, we'll be fine. Half the distance of VM, half T, halfway, -2, 7, -2, 7, and you represented half, and these are 1 to 1, because there's only 2 total sections. Awesome. Okay, so that was a 12-minute. Okay, let's see where we're at. Okay, proportionality. Cool.